All right, folks. So I want to, in this video, show you how to make a shield for some board like an Arduino, much like we discussed in class, and cover the connectors and just sort of making sure everything is aligned the way that you need it to be so that it will slot in if you make male connectors that should fit into the sockets of one of those boards with the female headers. So let's first start by looking at the pin types for whatever our board is that we're using. And I will, for this example, just go for the Adafruit Metro board. And I'm going to search for Adafruit Metro board pinout. And we shall see what we get. So we have this mini board, which is not our board. We have this Metro M0, which I don't know if this is our board. I don't think that this is our board, probably. But it's possible that it is. And yeah, we can see some interesting designations of what each pin does, which we should hopefully be able to interpret to make sure that our pins do what we want. But in general, all of these things that have GPIO are going to be able to handle turning our LEDs on and off. And let's see. Do we think that they do PWM? Most pins can do PWM, so I just search for PWM 2 through 12. These are general purpose GPIO. There's a dot next to each pad that can do PWM. Okay, great. So now when we look at this, we can see which ones can do PWM, and it's mostly this side of this board. So if this is the board we're working with, we're going to probably favor these pins with dots 2 through 12 because they're not only going to let us do a digital output, set the pin in output mode and do digital write high to turn the LED on or digital write low to turn the LED off. We can also do an analog write on these pins with dots from 0 to 255, and that will dim or brighten our LED depending on how big that number is, right? So that gives us a lot of flexibility and control if our goal is just to turn on and off different LEDs. So probably we're going to favor these ones if this is our board. That's the Metro M0 Express. There's also the Metro RP2040, which maybe this is the board we have. I'm not actually totally sure. This one, we can see all of the pins do PWM, it seems, and they just show us in this pinout right away, all of the pins doing PWM, and all the pins here have GPIO digital abilities. These analog pins just mean that they can read analog signals in. We can also set them to do digital output, just like our digital D pins. So basically every single pin on here works if this is the board that we have. So be sure you find, here's a Metro ESP32. I don't think this is the one that we have, but it could be. So again, we have different pinouts, GPIOs. It's not totally clear immediately which one's PWM. And here we go. I just searched for PWM. You can connect any of the available PWM channels to any pin. And we have some qualifiers here. So just read the pinout in order to figure out if the pins you're going to use to drive your LED match the capabilities and pick the ones that give you the most flexibility. So PWM pins, ideally. So let's pretend like ours is this RP2040. I don't know if it is or not, but these all share kind of a standard Arduino header layout that we're going to try to reproduce. And we know these things use 2.54 millimeter spaced headers. That's the standard header. And these are sockets, female sockets that we want male headers to slot into to hold our board on top of this one. And unfortunately, this is not just like one gigantic pin header. There's actually a little space that's done intentionally so that you can't misalign it and slot it in. You actually have to key it in perfectly so you can't like mistakenly put the wrong pins in here and put your ground into 3.3 volts. So they kind of intentionally make this a little bit off. So you have to then figure out how to account for that perfectly in your measurement when you put your own board together if you're going to try to reproduce multiple headers that align with these headers and smash your board onto this board. So let's start by just recreating this side, and that's all I'm going to do for this demo. I'm going to recreate this side and make sure we've measured this distance perfectly so that our pin headers are going to match this set of pin headers. And that should give you everything you need to do this assignment and build a shield that would perfectly attach to all of these headers. I'll say to start, you can get away with just doing a header that slots in right here and not have to worry about this and just do ground and one pin or ground and 3 or 4 pins and drive your LEDs off of this and it will work just fine. But let's assume we're going to try to do something that matches this entire side of the board. So first we'll do this header. Let's count 1, 2, 3, 4, 5, 6, 7, 8. So this header has 8 pins. So let's go into our KiCAD. Let's hit the A button. And you can see I've been adding connectors. And so the first thing we need to do is find that header. And in KiCAD, they will have the prefix CONN for connector, connector underscore. And that is going to bring up for us this connector dialog with all of these different connectors. And you can see a pattern here, right? We have the pins for the male headers and the sockets for the female headers. And we have 1 row by 1, 1 row by 2, 1 row by 3, 1 row by 4 pins, and so on and so forth. So what we want is 0, 1 row, X, 0, 8 pins, right? The 1 by 8 header. And I actually like this. We have a couple different versions that we could probably pick between that are more or less equivalent. I really like this generic one. I think it looks the nicest. So I'm going to go ahead and select CONN underscore 01X08, 1 by 8 header. And that is a perfect match for this 8-pin header. So that's awesome. And now I'm going to wire up an LED to a pin that is a PWM pin. So let's go ahead and do that. I can grab you, bring you up here, connect you up to now pin 2, grab you, bring you up here. Nice and easy. And then I'm going to need a ground. So I'll GND. Awesome. I'll just drop that in here. And that is now going to be all we really need to do to wire up an LED to this pin number 2. And pin number 2 here matches this D6. So now I know if I go into my Arduino code, I can set D6 to output in the setup part of the Arduino. And then I can just say D6 high to turn the LED on, or set D6 low to turn it off, or analog write a value and dim this LED to some value based off of that. So that's pretty exciting. But we have a problem, which is that this ground doesn't connect to this ground. And so nothing can possibly happen because they're not referenced to the same thing. So it doesn't make any sense unless we can pull our ground reference off of this board, and the 3.3 volt signal that's going to drive this LED, or 5 volt signal, or whatever it is from this board will actually set this to 5 volts relative to this ground, as opposed to something that is floating arbitrarily, right? So we really need to connect our ground. So that means we need this header in here as well. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's add, and we're going to search for CONN underscore. That's our connectors. We're in our dialog now. We can scroll down and find it if we want, but I'm just going to go ahead and type in 01X10, right? So 1 row by 10 spaces. And once again, I like CONN underscore 01X10, the generic version versus the pin or socket version. So I'm just going to go ahead and put that one in. I think it looks nice. Great. And that actually looks kind of physically like this side of the board. So that's great. We could add these other headers over here if we wanted to, drag these out. And that would be great. And we know we have 0, 1, 2, 3, 1, 2, 3, 4 is the ground pin here. So let's go ahead and I need to get out of that. Copy our ground, paste, and we know pin 4 is going to be our ground. And then we're going to wire that up. And look at that. We now have a completely working project as far as this class is concerned, at least on the design side. So we have one pin, this second pin, which is D6. We can command within Arduino to turn it on and off, and it's referenced properly to the ground, and it will actually do what we want it to do. So that's great. So now we need to make sure the physical layout matches. So first thing is getting the right footprint for these two. So my 1x6 or 1x8 connector, we're going to look at the footprints, and you will see a bunch of connector switches come up, connectors come up, a whole bunch of things come up. If we click into some of them, and look at what they give us, you see a bunch of different numbers: 1.25 millimeter, 2 millimeter, 2.54, 3.96, 5.7, all sorts of crazy shapes and sizes. And we know that ours is a standard 2.54 millimeter header. So I'm just going to type in 2.54 millimeter in the filter. And the first two things that come up for me are connector pin header 2.54 and connector pin socket 2.54. And we are doing a header. And we have a 1x8 header with 2.54 millimeter spacing. This one carves out a bunch of space as if we were laying the pins horizontally down on the surface of the board. So that doesn't really make sense for us. And then we have one that is vertical that's just like what we see on some of the other boards we've been working with where the header just goes slot straight in and we expect it to come straight up or straight down out of the board. So perfect. This is what we want. Pin header underscore 1x08 underscore P 2.54 millimeters or 2.54 millimeter spacing and a vertical version. So we will select that. And now we need to do the same thing for this guy. So footprint, where do we find it? We know 2.54 millimeter. And for me, I have it recently used, but we can also see connector pin header 1x10 vertical is the one that we want. Okay. With the holes, right? So if we look back at that, right, there are other ones, 2.54. There's some other ones. There's a surface mount one, right? If we wanted to get those little right angle ones that just sit on top of the board, we have that. We have a bunch of different things coming here. It's 2x5 for a 10 connector, 10, so this is with 2 rows instead of 1. So this is our obvious choice, this 1x10. So great. Okay, so there we go. We've now set our footprints. We can now go ahead and update our PCB. We're going to ignore what I've done. This is my little test circuit for class today, but let's just paste these in. There are connectors, and I'm going to go ahead and, positioning them is the big deal now. So we want it to look exactly like this, and we need to make it match perfectly to what a normal Arduino header looks like. So we'll rough them in. So now we have the top one up here and the bottom one down here. And so now we need to do some precise locating of these two headers. And in order to do that, I'm going to click this little settings icon, show properties manager, which is probably, I don't know if I'm ducking in the way of it or not, but it's over here. I don't know if you can see it. It's this little guy. And we're going to click that, and it's going to give us a properties dialog box that shows up when we click on these things. And one of the nice things that we can see here is if I click on the entire thing, I get an X and Y position. And then if I click on any one pin pad, I also get its X and Y position. And I can actually move it very precisely now. So if I change the X position to 20, it moves just that pin out to 20, right? So let's just undo that because that's horrible. But I can do that with this guy as well. So the first thing I'm going to do is we have our X and we have our Y. I'm going to make both of them on an easy to reference X. So maybe like 40 millimeters, because that feels like a nice, easy place to start from. And we'll move this one also to 40 millimeters. And now we know they're perfectly aligned. So we've done one piece of what we need to do. So that's great. So now let's try to fix, and I'm actually going to go ahead and take this upper one, and I'm going to move it to a very specific point as well. So let's just make that 40 as well, since that'll be nice and easy to reference off of. So 40, 40. And if I click this top pin, we can see that pin is at position 40, 40. And when we click this entire thing, it tells us its position is at 40, 40. So this object is referenced off of its 0-point pin. If I were to rotate this, it's going to rotate around that center point pin. So depending on the measurements that we look at to try to reference off of, we might be referencing off of this center pin number 1, which would be very common. A lot of times, if you look at engineering drawings, they will reference off of something like pin number 1. So now let's go try to find out what the measurements are so that we can place this pin exactly where it needs to go relative to this pin. So let's look. And so I'm gonna immediately, let's see. So we are on this page. You know, Adafruit probably has some technical download. So let's go to the downloads. All right, we have some CAD PCB files. So we could probably click on that and take a look. And we have this board layout file. So here we go. This is exactly the board, presumably, that we're trying to reference off of. And we can see we have 1.19, which I can only assume is inches. Yeah, dimensions are in inches. So that's fun. 1.19 inches and 2.15 inches. And that's referencing the center of this header to the center of this header. So that's like kind of gross and not super fun. But because these are going to be different sizes, right? So we really can't we can't assume that that is the same distance from pin one to pin one because it's not the same distance from pin one to pin one. But let's just do a little bit of math here. And so we have 2.15 minus 1.19 is the difference in inches between the center points of these two. So let's do our math. 2.15 minus 1.19 is 0.96 inches, right? So once again, that's from here to here, the difference of the center points. And that's because that's this distance minus this distance, and that gives us this distance, the distance between these center points. 2.15 minus 1.19, so 0.96 inches. And that's inches, and let's just convert it to millimeters. So 24.384 millimeters. Okay. So now we need to make sure the middle of this and the middle of this is 24.384 millimeters is our goal. So we can measure, and this will snap, this should snap right to the middle of these parts here. So let's go ahead and drop that right in the middle of this part, and we will measure, oh wow, we will measure it right to the middle of these parts. And we can see we're at 28.44 millimeters right now. 28.44 millimeters, and we want it to be 24.384 millimeters. So we have 28.44. We want it to be 24.44. So that is a difference of 4.056, right? So right now it is currently 28 and we want it to be 24. We need to move up 4.056 millimeters, this guy. We need to move up since this is the one we're going to try to move. Okay, so this is one way to do it, right? So we look at an engineering drawing. Now we're getting into a place where we actually really need to do a little bit of math and be able to look at an engineering drawing and recreate different distances, right? So we need to move this entire thing up, and we need to move it up 4.056 millimeters. Great. It is currently at 70.99. So I'm just going to go ahead and say 70.99 minus oops, I copied it. 4.056 is where it should go. And that's 66.938. And if we type this in, that looks like the right spacing to me. That looks right. Let's redo our measurement and make sure that it aligns with what we calculated earlier. So once again, what did we calculate earlier? 2.15 minus 1.19 minus 1.19, right? And that is in inches. Inches to millimeters is 24.384 millimeters. So we should get 24.384 millimeters if we go center to center. And we see 24.384 millimeters. So we've nailed it. So there's a little bit of math, a little bit of basic math here to just like get exactly the precise measurements. And if we wanted to do this other side as well, right, we can look at these dimensions and figure out how far this header is from this header, and we can set that X value for those connectors over here as well. So there we go. Um, we have our headers ready to go over here, floating in the middle of space. Looking great, ready to perfectly slot into our board. And just to reiterate, if we probably want that on the back of our PCB. So if I select these and type F, that will flip them. And if I look again at my 3D viewer, now they should be, if this is the top of my PCB, they are now poking up from beneath. And that means I can slot them right down onto that header and have some LEDs showing on top, right? So there you go. There is a basic tutorial on how to get this going. I will say, I believe that these are standard headers for the Arduino, and there's a little bit of math there. You may be able to find a slightly better engineering drawing that makes it a little bit easier to reference off of, say, pin 0 to pin 0, like the first pin of each one, and then just literally type in exactly where they go. But that may require a little bit more work to dig into. And honestly, you should still probably double check it against the header that is explicitly given to us to match this board in the technical drawing that they give us. But this is part of being able to do this kind of thing, is looking at a technical drawing and figuring out how to reference off of it. So like here's one, we can see this is nicely in millimeters. And this one actually has the first pin referenced. So if we subtracted these differences, we can basically one for one type in this difference, and this is going to be a little bit easier math-wise to deal with. This does not have the exact pin numbers for what our board has, though, so it may not actually work for the board that we have. So there's a little bit of a question of like, what is the right header layout for the board that we have. But it's good to get in a few reps doing a little bit of basic math and just making sure you can reference off of middle, center, top, whatever, and get the measurements you want. And there's a handy dandy ruler here that will always allow you to snap to the center of pins, snap to the center of the object, and measure and see how far off you are so you can type in your math and get exactly what you need out. All right, I hope that's been helpful. Looking forward to seeing all of the boards that you build, and drop into Discord if you have any problems. All right, talk to you soon.